Hello everyone, this is Dominic. Welcome back to my channel. Today I would like to talk about the launch planning and the simultaneous engineering. If you've seen my previous lecture, we are somewhere here. Today we're going to talk about the planning phase, the operation gate and the PLC gate, simultaneous engineering. These three big topics. Okay, the first page we're going to talk about is the project and operation milestones. Um, there are there are two bars here, as you can see. The green one is the project milestone, or so-called PLC milestone. Yeah, the product lifecycle milestone. This PLC system is very commonly used in the automotive industry. Almost every product or every component on the car follows this rule. Yeah, first is the concept design phase. You have a concept, you have a prototype, then you start to build the A sample, B sample, and C sample. Means your product iterates 3 times. Yeah, sometimes there are more than 3 sample phases, like a A0 sample or A plus sample, A1, A2, A3, and so on. Yeah, but today we just talk about the general concepts. So A sample, B sample, C sample. And the ADF is the A sample design freeze, and AMRD is the A samples delivery. Yeah, and so does the BDF, BMRD, 3D, CDF, CMRD. Okay, and this is what the R&D guys gonna do, and they will develop the product. And as a operation engineer or as a launch manager or AME, whatever, you have 3 rounds of chances to implement simultaneous engineering to make your product manufacturable. Now, you should keep in mind that today's automotive industry, as a tier 1, you should know that at the B sample phase is a very, very crucial and a critical one. This is like the connection between the sample prototype building and the serial production. At the B sample phase, your product line is going to be kick off. So what you're going to do is you make sure that the industrialization kicks off as late as possible. Well, at the best is a B sample phase. Some companies are crazy. They start their product line at the A sample phase, but it doesn't matter. Okay, so you need to keep in mind that as an operation guy, you need to do the following stuff, as the blue bar shows. Yeah, you have the line kickoff and the planning and sourcing. You need to pick the supplier to build the line, and you need to nominate the supplier. The line goes to the design phase, the build-up phase, and the pre-acceptance. And the pre-acceptance is normally done at the supplier's place, but sometimes if you are really rush in the project, the product line could be shipped into a factory and do the pre-acceptance. Then the product line transfer to your plant, the rebuild, and you're gonna build the PV samples, PPAP, SOP, the final acceptance of the line. I've listed out the milestones of the operations. So the green bar and the blue bar, these two goes parallel. They don't start at the same time, but they're gonna meet finally at the PPAP phase. Yeah, they're gonna meet at this point. So this is basically the overview or the framework of the R&D and the operations cooperation model. Yeah, and you need to keep in mind that, or you need to know that as a operation guy, you need to help the R&D to make their product manufacturable. Yeah, and you need to give them a lot of design for manufacturing ideas. And around at the A sample and B sample phase are the time slot that you give a lot of output. Yeah, and I will explain what kind of information you need to confirm at the A sample phase and the B sample phase in terms of operation or in terms of product, process development. Okay, let's go back to this chart. If you see uh, for every milestone, the red triangle, I have the condition, or the so-called exit condition, or exit criteria listed out in the boxes. Yeah. From the line kickoff phase, that the design is quite solid and it is manufacturable. So you can start to kick off the industrialization. And for B2P, some of the parts you don't build the line by yourself. You need to search for the source, or need to search for the build to print supplier. Yeah, they're gonna build it for you, and you need to do a lot of make or buy decision, and to calculate the price to see is it cheaper you build in-house, or you do it outsource. And manufacturing cost, I will cover this in the future lectures. And the investment decision. This is quite crucial in every company, that you're gonna calculate a lot of costs and take the data to your boss or to the CEO to let him approve the investment. Yeah. Then the next one is the SOR review. The SOR carries all the technical and the management requirements in one document, and the supplier is going to build the line according to this document. So this is very, very important. I will explain the SOR in future. Yeah. What do you do? What do you write in the document? Mm. Okay. And next one, IT requirement. You need to gather information from your local plant IT, and you need to carry their requirements in your SOR. And safe launch plan. What is safe launch plan? Safe launch plan is there are two understandings. First one is when the line start to run in your plant. The early phase, you can call it safe launch plan. This is a very general saying. Or the second one is more accurate. Is in the early manufacturing phase, you need to put a lot of extra measurement, or extra activities to make sure that the product is designed according to the quality requirement, or fulfill your quality requirement. So we call that phase safe launch plan, because this safe launch requires more measurement devices or more effort. So there's a cost in it. So you need to plan it carefully. A rework plan, you need to also understand that you must make sure your product to rework in your plant. It doesn't matter if the product is reworkable. Yeah, if it's not reworkable, like inverter, a lot of processes they are not reworkable. Then so be it. If it's reworkable, like the final assembly line, you need to plan the machines, or not mostly manual machines, to rework, and how the line gonna deal, how the serial product line gonna react if there is a NG part. Yeah, the rework plan. The next phase is supplier building, and the capex application, of course. And during the line design phase, you need to make sure that the 3D of the line will be reviewed by all the stakeholders, the R&D guys, the operation guys, and the supply. Sometimes the quality guys as well. Yeah, make sure this review is very crucial. Make sure everybody participates. Then CCB is you there normally from the start of the design of the line, and until this phase, there will be a lot of change. Yeah, there will be a lot of changes. The product changes, the line requirement changes. So you need to list out every change, where it come from, and why do you need this change. Do the price calculation. And normally the audition team's gonna look to the changes first, because there could be a lot of corruption in these changes, because there were normally these changes, these investment are single sourced. Yeah. And packaging and logistic plan, of course, the product logistic plan must be designed, and the package must be designed. Every plant, there are package designers, logistic guys. Make sure they're involved as well. Yeah. Then the pre-acceptance, you need to list out what do you need to do in the pre-acceptance phase. I can give you a list in future in the following lectures and show you what do you need to check on each machine, how to do the pre-acceptance. And CCB, of course, make sure it's implemented. Then the plant production field is accepted. You need to give your plant team the information about your line. Normally there are several information that you need to give them: the layout chart, layout drawing, um, the energy consumption, and uh, the compressed air, and and so on. Yeah, and all these information there could be concluded in some standard documents that your plant's gonna give you those templates, and you need to fill it. Then the plant gonna kick off the kick off their uh, infrastructure build. Yeah, according to your line. Then, when the line arrives your plant, you need to do the process release. What is process release? You need to make sure that the line can produce the good part, and the process is solid, and it can be done, it can perform nicely your machines. So you do a process release. It's a different from PV. PV is the the whole product level. Sometimes some critical process, you need to check them one by one. For example, for soldering or for laser welding process, you need to make sure that the process, the pulling force of the copper is okay. Yeah, and the plant BOP must be finished. I will explain the BOP in the future. And SAP data, of course, that's the plant IT's work, and the plant mass is ready. And this is also very important, the mass part. You need to make sure your plant IT guys need to go to your line supplier's place and to work with them before the line ships out. And when the C sample is finished, the at the OP70, the C sample is finished, safe launch executed, and the product line doesn't have severe problems, and you can ESO is passed. Yeah, all these criteria meet, and your line can go to PPAP phase, and you can perform the PPAP. And the after the PPAP, you can have official SOP celebration, and then the line keeps running for several months. Then you start the final acceptance phase. Normally, the final acceptance will be started after the line works 6 months later, yeah, in your product field, and the line is okay, and you do a lot of stuff like what you did in the pre-acceptance phase, and then do the final acceptance and make sure the supplier and you clarify the aftermarket service. If your line is broken down, or if something's wrong with your line, who's gonna do the maintenance job? And what's the supplier's duty? And what's your plant ME engineer's duty? You need to clarify it. Yeah, and this phase. Okay, this is pretty much what you do as a operation guy. For the whole industrialization. What do you do in the whole industrialization phase? Normally, this blue bar runs for 2 years. In China, it's much faster. They can build a 200K production 200K productivity line in 6 months. So from the initialization of the industrialization until the PPAP, 1 year is enough. But in Germany or some European countries, they're much slower. They could be 2 years or even longer. Yeah. So this is basically a conclusion from my experience. We talked about A samples, B samples, and the C samples. So what are those? What are those? What are the differences between the A samples, B samples, and the C samples? Let me give you an example. You can see this housing. This housing looks really shiny. This could be a inverter's housing. It should be the material should be aluminum, and in serial production, this should be die casted like the right one. Yeah, but at the A sample phase, sometimes B sample phase, they CNC it because the molding, the tooling is very expensive. You don't build you don't build the tooling for just the 10 to 20 parts. Yeah, so for A sample and B sample, a lot of the components, their maturity has not reached the final. So not only the housing, some other parts also. For example, copper bus bars and the injection molding, they do it in another way, or other parts. And another example would be the stator lamination. The stator lamination in serial production is punched. Yeah, it's punched or stamped in the stamping machine, and then it's riveted together or automatically to do the lamination stack. But in the early sample phase, it could be wire cutted each piece, or they do a manual punching tooling. Yeah, it's also possible. So for A sample, B sample, C sample, this form listed out the differences. I will not read them one by one. You can go through it, so you will have a understanding on on the differences of these sample phases. And again, I need to emphasize that B sample is very, very crucial. A samples, you need to participate as much as possible. For earlier sample phase, for example, concept sample, most of the works are done by the R&D. Yeah, unless you are AME, you should develop the process together with the R&D guys. Okay, the next topic we're going to talk about is simultaneous engineering. So, what is simultaneous engineering? I've heard this concept 2 or 3 years ago. It's basically just the two tasks do it in parallel, and then you can call them simultaneous engineering. It's very easy definition. I've written the official definition here, but I want to explain it in another way. And for your operation guy, you need to improve your process maturity along with the product maturity or design maturity in the same time. Make sure it is manufacturable and before it reaches C sample. As I had said, make sure the B sample can go to the product line, and then you are successful. In each sample phase, you take the chances of sample build to iterate your process, and then or you conduct independent experiments, yeah, independent from the sample build. This is what you do to improve your process maturity, or you can call it the simultaneous engineering. And normally, yeah, as I written down, normally B sample is crucial, and make sure B sample reaches a certain level. Then I will explain what is the process maturity. Product maturity, you already know, A sample, B sample, C sample. Process maturity, I've divided it in several sections. The first we say process parameter. Of course, in the machine, the torque at the serial production machine or at the the prototype machine, you have a torque. If you do a screwing process, and you have a rotation speed and whatever, or use voltage, electricity, current for your soldering or welding process. This is process parameter. Uh, there are machine parameters and performance parameter. What I've just said is machine parameter. These parameters can be achieved during the sample build in A sample, B sample, but for each time you change the machine, you need to re-achieve these parameters. And finally, in your serial production machine, you need to lock the parameter again. But for what is the performance parameter? This is like how strong the connection force should be if you use the screwing process here, or how strong the connection force should be if you use a soldering or welding process here. This is a performance parameter. I will explain them later. And machines, fixtures, of course, you need to choose the machines or select the machines. And you need the suppliers design your serial product machines. And then the process related design. And the product features for assembly. Is there any supporting features for your fixtures on your product? Yeah, for example, or is the hole big enough for your screwdrivers to reach in? Yeah, this is very commonly this is very common for the design for manufacturing ideas. And this next one is the product features for machine or other processes. For example, if you is this space wide enough for soldering, or is this space or is this surface cleanliness okay enough for welding? Yeah, just like those. And then the process experiment. Process experiment, you should conduct. You need to conduct some DOEs for your process to optimize your process parameters. Yeah, and the product performance related experiment should also be done. For example, you want your glue. You choose the process gluing here. If the product should go through 300 circles of thermal shock, and how many rounds of thermal shocks it should be the bottom line, and your R&D guys should define this, and then you can say, okay, I chose the gluing process here to make sure part A and part B can withstand all these thermal shocks. Yeah, or you can say gluing process is not okay. I will switch it to soldering. Yeah. And this is very this this part I listed out with the um, red rectangular, and also this one. These two R&D guys gonna give you a lot of information, or you should work with them and make sure they are back and forth. You need to bargain with them. Yeah, then you need to choose the process the process as commonly used as possible. Yeah, and then the process reliability, consistency. You need to know that we don't build. We use the process not only to build samples, but also we need to build thousands of our products. Yeah, you need to make sure your process is uh, very easily maintained and very cheap as possible, and as stable as possible. So there are several criteria that can check your process. MSA, these are for checking the measurement machines, and CPK, CMK. This is for to check if your process is stable enough. Yeah, and the process reliability. Of course, there's error proofing, Pokayoka stuff to make sure that your every process, if the operator want to make a mistake, he cannot make one. This is error proofing design. Then at last, the manufacturing cost. Manufacturing cost, you need to calculate the cycle time, machine cost, operation cost, machine time, whatever. I will explain them in the future lectures. All these factors you need to clarify. Then you call it my process maturity can reach a certain level, or can reach a serial product level. Okay, now I'll give you an example of the process maturity. This example is about laser welding. We've done some process development of the laser welding. And if you don't know what laser welding is, There are tons of materials or videos on the internet. You can search for it. Yeah, I'm gonna introduce the methodology to how to do the process development. I'm gonna break down the factors that consist with the laser welding. If you, as I showed in previous slides, if you clarify all these factors, yeah, if you clarify all these factors, you can develop your process successfully. If you have no clue what this is or how to develop this process, remember, go for the experts in the industry. Who are the experts in the industry? They are your suppliers. There are professional suppliers on every technology, basically. For laser welding, for example, there are two iconic suppliers, IPG and the Trumpf, whatever. Those are two big players. You can contact their sales and say, hey, I want to weld these two materials. Please help me develop a process, or let me try at your machine and give some and figure out some process parameters and see the feasibility of the serial production. They'll be happy to assist you, or they could charge you money or do it for free for you. It's all possible. Yeah, make sure you know where to search for help or where to search for consultant. On these are the pictures about the laser welding. On the left one is how the machine works. Yeah, you can search for some other materials. I will not explain them in detail. And the second one, this is the pulling force test. After you laser two pieces of copper together, you need to do the pulling force test to see if your welding seam uh, is firm enough. We're gonna talk about there are four types of weld. There are a lot. Of course, there are more. I've given examples of four types of weld, and we use this one a lot. We use this overlap weld a lot. This overlap weld means there are two layers of copper, the one on the top and the one on the bottom. The laser beam come from the top and melt down the copper at the top layer, and then melt half of the copper at the second layer. And these two layers of copper will be glued together. And this is one of the most commonly used situations in inverter design. Inverter design, you use this a lot, and also butt weld. This also, yeah. Okay, let's see the details about the laser welding. Let's see the detail about the laser welding. Let's look at this chart. I will show you the original file. Yeah, process parameter, machine fixtures, process-related design, process experiment, reliability, consistency, manufacturing cost. These are the big factors, and I put this machine parameter and the serial production machines fixtures. These two I join them together, or there are some overlapping information. Okay, I will go through them one by one. First, the machine parameter. You need to know what kind of welding seam you need to do. Is it linear or spiral? Or you can do it both. Yeah, if it's linear, you need to only take care of the weld beam width, height, length, and so on, and probably the depth. Yeah, and if it's spiral, then they are much more complicated. There will be the size of the weld seam, the inner circle power, out circle power. If you don't understand all these technical terms, it doesn't matter. Yeah, you can ask your suppliers or search for the detailed information on internet. Yeah, the basically all there could be more factors that influences that spiral welding quality. Yeah, you can search them out. Basically, you can if you clarify all these criterias, then you can see, okay, you can say to yourself, okay, the machine parameter, basically I have all of them. The machine parameters will be iterated several times. You can perform the welding at the supplier's prototyping machines. Then you buy one machine by yourself and you perform again. The the parameters will be changed. Yeah. Then you do it again at your serial product machines or serial production lines. They will be changed again. But as long as you know the methodology, then you will be clarified, or you can have confidence. Say, I can I know how to achieve the machine parameter, and then the performance parameter. This one will be a lot of them will be given you by your R&D guys. If they design a product, they want to use the laser welding, and they need to give you the shearing force of the copper and the bead size of splash. What's this? During the welding, during the welding of copper, the the copper may be the liquid copper will form into the size of the bead, and the size of the bead is very crucial in the electronic devices because it may cause a shortcut on the PCB board. You need to be very careful. So how to control the bead size and how to control the splash? There are a lot of methodology to do this. Melting zone depth, so-called MZD, and this is very important as well. If the melting zone is too deep, then you may burn through the material. Yeah, this is not acceptable. Heat affected zone, also the bubble size and numbers. This bubble means the air. There could be bubbles inside the copper. If you cut it open, and you will see it. Yeah. Uh, this bubble size also affects the conductivity of the currency. If the conductivity overlapping size or area is not big enough, there could be a heat generated, and you may burn the product. Okay, so then the next one, prototyping machines fixtures. The gobble scanner selection. If you selected the machine, you need to select all these important components. For example, the gobble scanner, laser generation, the laser generator. I need to take care of. If you do the simultaneous engineering, well, the most ideal situation is you use the same machine as in your serial production. If you already have a product line and this R&D want to build a new prototype, you can try it on your serial product line as long as acceptable. Then you will have the very firm or reliable parameters that you don't need to iterate. Yeah. And serial product machines and fixtures, you need to take care of the moving equipment precision. For example, if you use a 3-axis system or use a robot to carry your laser welding generator, the accuracy of those components will be very crucial. And the focus position, the focus position is higher or lower than the welding surface? The distance measurement position. You need to measure first. You need to measure every time when the laser the laser generator or the gobble scanners, the distance between gobble scanners to your laser service, to a welding service, the distance. Every time you need to do a long online distance measurement, and this will be checked by the MSA. And heat affected zone, of course, sometimes you need to bury a lot of thermocouples, and you need to monitor the temperature field, and a lot of power is going to be given into your copper bus bar, and you don't want to burn the electronic components nearby. So you need to monitor the thermal the the area of the thermal zone. Yeah. The thermal field. Then the ventilation design. During the welding, there will be a lot of gas. There will be copper gas and there could be smoke, and the smoke will block the laser. So there should be a ventilation structure. One there will be like a small device that the compressed air go through one end to another and take the smoke away. This is a ventilation design for the laser welding. And the protection of the gavel scanner. The gavel scanner could be polluted. Yeah, you need to make sure that it will not be damaged by your copper splash. And the fixture pressure. And if you put the pressure two layers of on the 2 layers of copper, you need to take care of the pressure, not too big, not too small. Make sure the 2 layers of copper combine together. And the fixture clearance space, of course, monitoring equipment, like I just mentioned. Yeah, you will be monitor a lot of stuff. Then the process-related design. Um, for the features of assembly, you need to the supply the R&D is going to give you the thickness of the base material, and you need to choose your powers carefully. And then for the machine on other processes, there will be material selection. You know, normally it's done by the R&D guy, and you will try the weldability or the feasibility of welding of these material. Cleanliness very important. If there are a lot of oxidized material on the surface of the copper, there will be a lot of splash. Uh, and the flatness, of course, burr size requirement. The burr size as will be as small as possible, but there won't be zero. So you need to let your R&D guy know. Yeah, if I want to measure weld this seam, there can be burrs around it, and you need to give them back the information and let them put it on. Then there will be the process experiment. You need to do the welding DOE. Need to do the welding DOE, and then you need to do. You need to check a lot of welding quality, like the pulling force experiment, shearing force, and the metal graphics sectioning. Yeah, this will be done during the process development and do the regular check in the future serial production. You need to perform all these check. And then the process reliability and the consistency. You need to check the MSA of the camera, the MSA of the distance measurement, and you need to check the CPK, CMK to check if your laser source or the laser generator is stable enough, and the reliability, error proofing, and you need to make sure the detection of methods experiment. You need to make sure the splash, for example, the splash, the copper bead, will be detected if there is one, or you either by camera or by human's eye. You need to choose a method. The camera has its limit. Sometimes it's impossible to do it all automatically. Yeah, you need to make sure if there are copper beads on the surface, how do you detect it, and how do you remove it? Then this is called error proofing. Okay, at last, the cycle time, the manufacturing cost, the machine cost, and the operation cost. If you find the laser welding is okay, that from quality point of view is okay for you, from cost point of view is too expensive, then you may need to consider another type of welding. For example, resistance welding, or brazing, or some other type of welding. Then it's a whole new story, and you need to develop the process again. Better clarify the manufacturing cost first. Then is it acceptable from the controlling point of view of your product design? Okay, finally, I've listed out all the process maturity levels criterias. I compared it with the NASA's technology maturity level. As you can see in this form, on the left part, uh, wait a second, okay, this laser beam. On the left side is the NASA's rocket maturity stage. Each each technology is developed from basic principles, and it could be successfully tried in different levels. For example, at the laboratory, uh, and at the prototype and the prototype demonstration at a operational environment, on the actual flight qualified and the actual flight and on the flight mission. So at the different stages, the technologies has proven valid or proven successful. Um, it's the it's the symbol of the process development success. Yes, or so the technology development success. So here are the descriptions of each stage. Similarly to this to this evaluation system or assessment system, we can assess our laser welding maturity, laser welding process maturity. Let's see this column, different stage, different stage description, fundamental principle of the laser welding identified. You need to know what kind of material you need to weld, and what kind of theory behind the laser welding. Then the initial process concept proposed for material and joint types. This means you need to know what kind of joining do you need, what kind of shape or what kind of structure do you need, and or is it weldable that you need to try. Are these materials you chosen, are they okay to weld? Are they feasible to weld? Then feasibility demonstration. You need to, through the lab scale test, you need to weld some prototypes in the lab, and see is it possible to weld these two materials together. Then the process parameters. Basic process parameters. This is this is starting to get serious. Yeah, you need to try out in the actual on the actual machine that already been performed or already been on the market on sale. So you try your product on the welding machine that already exists, and you get the process parameters. If there's no such machine exist, you can ask the supplier to develop one for you. Yeah, and for example, the for the power module production for Tesla, they developed all this sintering process, yeah, for the power module. They have to develop whole new product line or the whole process. All the all the process is carefully developed. A lot of machines are brand new that does not exist in the industry, and then process validated on the actual joint configuration under simulated conditions. And you can do it on the samples, yeah, on the samples. Then the full weld prototype make under the production like conditions. You can do it on the actual samples, B samples or A samples, and do some validation tests, and then process demonstrate on the production parts using pre-series tooling. This is getting the serial production phase, and you need to check the process repeatability. Is it okay or is it stable enough? Then the process qualified documented for mass production. Then you need to pass the PV, pass the PPAP, and so on. Yeah, then it's proven the serial production with a stable quality and yield. This is a huge difference between our automotive industry and NASA's rocket science, the rocket or aviation industry. Most of the NASA's technology are used once or less or several times, but our process system is developed or is built to copy to make copies of the product as cheap and as accurate as possible. So you must make sure your process repeatability is perfect, or it's okay, or the failure or the failure chance you can accept, or the or so you can call it the NG rate is acceptable. Yeah. So this is the form that you can use to evaluate your process maturity. In the middle column here, I listed out the common criteria to assess the process maturity, and you can see there are you can it can be divided in three phases. Yeah, the concept sample phase, the A sample and B sample phase. What you're gonna do at the A sample and B sample phase is very clear. Yeah, and then the C sample phase is goes to serial production. So you can use this form to evaluate your process maturity in the future. I only gave laser welding. I only gave laser welding as an example. For every process, there should be a roadmap to improve its process maturity, from screwing to to the assemble to the special assemble. For normal assemble, there's no need. For the special assemble, for example, some special pressing, you need to you need to keep it in mind. You need to develop this process. Um, okay, so that's all for today's content. If you have any questions, please leave a message to me, and I'm happy to answer your questions. Looking forward to it. And send me emails. Thank you.